Alright, to finish up with mirrors, we're just going to finish up with a couple of examples. We'll do one more written, and then I'll show you an old diploma example. So we have an object, it's placed in front of a concave mirror. For sure, it's always important to know what type of mirror you're working with, be it concave or convex. So we're told that the focal length of this mirror, it's 15 centimeters, and we're told that the image is magnified by a factor of negative 1.50. So we want to determine the distance of the object from the mirror. Alright, we got a lot going on in this question, so let's see. So it's a concave mirror. We know that that means the focal length is positive. So we're told the focal length is 15 centimeters. We can just leave that be. And we're told the magnification is negative 1.50. So we would like to determine DO. Now with that said, let's see what we got going on here. So we have our mirror equation. So we got this 1 over DO plus 1 over DI. We would like to find DO. But let's rearrange this for 1 over DO. Like we'll keep this by itself. So we're going to subtract the 1 over DI from both sides here. So I'm going to get 1 over DO equals 1 over F minus 1 over DI. Now, we know F, it's given in the question, but we don't know DI. So this is a little bit of a problem. We can't proceed any further. We're stuck. This is where the magnification comes in. We're told it's negative 1.50. We also know the equation for the magnification. It's HI over HO, or negative DI over DO. Again, I'm not provided any information about heights, so don't care about that part. I could just say the magnification is negative DI over DO. Now what I do know in here is I know the magnification. I don't know DI or DO, but I'm actually trying to find DO. That's the overall objective here. So what I'm actually going to do is, first of all, I'm going to rearrange this for DI. So I know that DI is just going to be negative MDO. Don't forget that negative here. So that negative is just going to go to the other side. We're going to divide both sides by negative 1. That's going to go over here. And then we know the magnification is negative 1.50. And then again, we don't know DO. So negative and negative is going to make positive. So what we know based on the magnification equation and the magnification itself, we know that the image distance, it's going to be 1.5 times the object distance. What we can do is we can take this and we can put this in the equation here. Now I've kind of gone ahead of myself. I probably shouldn't have rearranged this so hastily, but it is what it is. So I have this 1 over DO equals 1 over F minus this 1 over 1.50 DO. Well, I have DO on this side, I have DO on this side, so I'm actually going to undo my mistake. I probably shouldn't have done the rearrangement first. I got ahead of myself. So I'm actually going to bring this piece back to the other side just because I have those DOs over there. So we're going to add this 1 over 1.50 DO to both sides. So my mistake, I got ahead of myself. So I have this 1 over DO plus this 1 over 1.50 DO equals 1 over this focal length, which I guess I can plug in now and say it's 15 centimeters. Now, once again, like the last time, we could almost get this that almost looks similar, but we don't have a common denominator. I have a DO here, and I have a 1.50 DO here. Well, what we can do is we could make this a common denominator. We got 1.50 DO there, which means we're going to put 1.50 up top. So now I have a common denominator of 1.50 DO, and then up top here I'm going to have 1.50 DO. So what we get here is 1.50 plus 1 is going to be 2.50 over this 1.50 DO, and then we have that over 15 centimeters. So like I said, I did some extra work that didn't actually help me out. Probably should have been a bit more careful. It is what it is. So I have one fraction equals another fraction. Let's do what your math teachers hate. They hate me cross multiplying. So 1.50 DO times 1, that is going to give me 1.50 DO. And then we have this 2.50 times 15. What's that going to give me? I should be able to do that in my head. What is it? Is it 37.5? Yes, it is. 37.5 centimeters. So the last thing that we want to do here is we just want to divide both sides by 1.50. So we're going to get DO. We're going to get that the object distance is about 25 centimeters, and actually it should be 25.0 for significant digits. So based on using the magnification equation and the mirror equation together, we're going to get that DO is about 25.0 centimeters. So this idea of having to sub in DI into the mirror equation with DO, that's a pretty common type of question that's also occurring. That also occurs very frequently on the diploma. So watch for that. And then the last thing, let's actually look at a diploma question with a multiple choice. So let's see what we got going on here. So we have a girl, she's 122 centimeters tall, and she stands 40 centimeters in front of a particular mirror. So her virtual image in this mirror is upright and 54 centimeters tall. Let's label what we have. So we're told the girl, she's 122 centimeters tall. So we know HO is going to be 122 centimeters. And she stands 40 centimeters in front of a mirror. So that's telling us DO. Now, we're told she has a virtual image. So this is telling us that DI is going to be negative. We're told her image is upright and it's 54 centimeters tall. So that's telling us HI is positive 54 centimeters. Now, let's see. The mirror, we want to know information about the mirror, whether it's convex or concave. We also want to know about the girl's image. So we need to find DI. Now, some people might say, oh, virtual image, automatically a convex mirror. Be really careful. A convex mirror will always produce a virtual image, but a virtual image is not always produced by a convex mirror. As we saw with that special case, a concave mirror can produce a virtual image if the object is located between the focal point and the mirror itself. So we've got to be really careful with that. So HO, DO, HI, and DI, those are all related by this equation, this HI over HO equals negative DI over DO. So the objective here is to find DI. So we're going to multiply both sides by DO. And then we're also going to just divide by minus 1, which means we're just going to transfer that negative to the other side. So what we're going to get here is DI is the negative of DO times HI over HO. And this is why I made the variable list, just because we have 3 different types of lengths. We want to make sure that we are accounting for the right ones. So we have this negative, so we're told that DO is 40 centimeters, HI is 54 centimeters, and then HO is 122 centimeters. So we got a lot going on here. So what we're going to get is we're going to get about negative 18 centimeters. Now this is where we can kind of stop to do a little bit of a check. We're told the image should be virtual. We get a DI that is negative. That's good. This is consistent with the problem. So if you're getting numbers that are not consistent with the problem, that's a sign that you got to recheck what's going on. So we get a DI of negative 18 centimeters. This is telling us our image is located 18 centimeters from the mirror. So for our options, we're going to take care of 18. So we have to determine whether it's a convex or a concave mirror. Now, to do that, check the focal length. So if you want to determine this part here, we're going to check the sine of F. You don't actually have to calculate the focal length. We just need to determine whether it's positive or negative. So we know 1 over F is 1 over DO plus 1 over DI. Well, we are told that DO is 40 centimeters, and then we're going to add to that this negative 17.7 centimeters. And then we do that. We are going to get, sorry, I mislabeled this. Sorry, I'm just trying to punch this into my calculator, and I am doing the mistake that I tell students not to make. So we're going to get that 1 over the focal length, it's about negative 0.031 centimeters inverse, which just tells us that the actual focal length of the mirror is about negative 31 centimeters. So from this I could just say, well, if this is 1 over f, f is negative 32 centimeters. We don't actually have to calculate the focal length. Since f is negative, this is telling us that we have a convex mirror. But if the inverse of the focal length is negative, the focal length itself is going to be negative. So if we know the focal length is negative, this tells us that we're dealing with a convex mirror. So we have a convex mirror, 18 centimeters, so the answer is A. With all the mirror questions, I can't emphasize enough how important it is to be really aware of the sign convention. If you're aware of it and apply it properly, you'll get every mirror question right. You'll be fine.